Welcome back everyone. Today we're in day 4. We built our authentication system and also have laid out a little bit of groundwork for our game service. This is all for our to-do list project, which you can find the repo on the video. You can also find as well the playlist for other videos as well for the other days that we've done. We'll also go through how my authentication works in my code and what we've used for it, and I'll also go through a little bit of what the groundwork looks like for the next few features I'm going to implement. I will also show you a live demo. Last time I wasn't really able to show you that live demo, but we are planning on doing that today. What we'll also go through as well is a couple of things in terms of how it all links together, and also a little bit of what's coming next at the very end, so all of you have an idea about what the next videos are going to contain and where we're at. So, how does our authentication service work? Well, essentially, our authentication service is responsible for handling login requests. So, for those of you who might be unsure what I mean by that, most people have login details. You've got loads of them. You've got them for your emails, you've got them for your banking, all of that kind of stuff. There's loads of different services where you need a username and a password, and ours is no different. Now, I will say what I'm about to go through isn't going to be in as much detail as a video that we have on the channel, which goes through how you can set this up yourself. This is more of an overview of specifically how it's implemented in this project that we're going through today. So, this is our class for our authentication service. Now, what you'll find is we've got the implements here. Now, the reason it does that is it implements this HTTP authentication request provider, and it does that because this is what Micronaut looks for when it comes to its Java Web Token security for your authentication. And if it finds a provider, which it does, our authentication service, that's what it will use. You'll see we've got a B there in those bits. What that means is that's just a placeholder for body. Now, the reason I've done that is currently we are using a HTTP request with just a username and a password, but you might want to have different sorts of login bodies. They might be different objects, it could be anything. If that's the case, then I've left it as a placeholder to allow it to be generic so that you can go out and alter that if you wanted to. Next bit, after we've got through that, is a couple of things that we've added. So specifically, we've also got the option when we go down here for authenticate, where it will take out the username and the password. Now, it does that by using an object that we've called authentication request. Now, put simply, all that is JSON that gives you the username at the start and the password afterwards in the key value pairs. Now, for myself, the body or the context of what this is going to come through as is another HTTP request. Within that is the authentication. In our case, it's just 2 strings, which is the username and the password. Why do we have it as non-null and nullable? Well, the nullable part is the context, so it doesn't have to have a HTTP request, but what can't be null is the authentication request, all right? It also can't have a null response. The reason it can't have a null response is you can't have something else besides an authentication response, whether it be a pass or a failure. How have we assured this? We've done that by using a try-catch. So if you have a look at our method, we've got a try-catch there just to handle any unexpected errors in a controlled way to avoid anything running loose. When we go through it, I'm going to go through this stage at a time. You'll notice we've also got a couple of single system out prints. Now, those system out prints are there to keep track of what stage it's at. I use it personally. Other people also use what's called breakpoints, which is where you can get the code to go through one line at a time and to see if there's anything that goes wrong. I've only done it purely that way because I just find that easier. It's good if you're doing small chunks of code, not so good if you've got massive chunks of code. You'll see we've got the username and the password. Okay, we've done that by getting first the username with identity and then getting the secret. Okay, secret's that second part of the authentication request. Username is the first part. Okay, now when we go through, you'll see we got an authentication adapter service for find username. Now, it does that because it will locate in our database that we've built. I already spoke a bit about that previously. We've got usernames and passwords. Now, how it works is it will look for that user. Once it's found the user, it first checks to see whether it's null. Now, it does that because if you try to log in and there isn't a user there, then can't log in. So we use an if statement to cover that, where if the user's null, it will say the user's null and it will return a failure, okay? Because they're not authorized, they don't exist as a user. If they aren't, then the code carries on and ignores that part. In our case, it checks the password using a password hasher. I will say, guys, I'll go over how this works in my code a little bit more. Just keep what I say in mind for now. It checks the password by seeing if the normal password that we've got matches what's called a hashed password. Once again, we'll go through that in a minute. The best way to think of that is encoding, so changing it to look like one thing into something else for the purpose of security. As I said, we'll go through a little bit more in a bit. Once it's happy, if it is happy with that, then it will say authentication success, and it will return the authentication success with the username along with the role of the user. Now it does that because a user might have different roles. They might be, for example, a admin user. They might be a normal user or a customer, whatever it is. You can use the authentication success to sign the JWT token with a username along with a list of what their kind of roles are. Once again, you're going to see what that looks like in a minute, guys, so please don't panic if you're struggling along just yet. If it isn't a match for any reason, then it will return a failure. Alright, that's simple. And if anything goes wrong with the code and the catch, then it will also return a failure, because we can't still let people go through verification anyway, and also it can't be null, so it has to send back something. That's it for the actual authentication service. Now, to help break this down a little bit more, I'm going to go through what I've added, what each kind of library, what each object that this uses is, and the methods attached, and then I will refer back to this so you can see it yourselves. First one is password hasher. Now that one, guys, quite simple. The password hasher simply just encodes the passwords. Now I'm going to show you what this looks like in our authentication folder. We're using what's called bcrypt. Now, password hashing, for those of you who don't know, essentially it takes a string and then it will encode it to look like something else. Usually it's a bunch of random letters and numbers. It does that surely for security. If, say, a user was trying to log on and there was any cyber incident, or say someone's trying to intercept the request as a man-in-the-middle attack, for example, then that stops that user, criminal, as to what the actual password is, because they don't know, because it's not there. Now, when it does that, you'll also find we've got the two methods, hash password, and we've also got check password. Hash password, in simple terms, simply gets the string, encodes it, and returns the response. Check password takes the unhashed password and looks at the hashed password and see if bcrypt is happy there's a match. Okay. Now you're probably wondering, how does it know it's a match? It knows that based on what kind of password hasher you're using. There are things you can add at the end, for example, to try to get them a little bit more safe and a little bit more secure. But I will say most things are typically, well, not most things, how do I describe it? When you go onto a website, for example, you can find in some places a list of what hashed words look like. Now that is why sometimes people will add something at the end, just for that extra layer of security. But password hashing is a good way to avoid someone seeing what the password is raw, because once something is hashed, you can't unhash it. The only way you know what it is through surely brute force. So just by hashing yourself and seeing if a random word that you're giving matches the hashed version, which is really hard to do, because as you can imagine, it's a lot of words in the English dictionary, and same as every other dictionary. So good luck with that. But that's it with that one. And the check password, that's all it does. So that's it for the password hasher, and that is all my authentication service does with that. The next part is the entity manager. Now, for those of you who don't know what that is, essentially that helps persist what I alter or what I retrieve from the database. So in our case, for our data sources, we have our local database running on a local port, and that's what the entity manager will access. And it means we can interact with that database. That's all it does. Now, as well as this, you'll also see that we have auth adapter service. Now, the reason we've got the auth adapter service is that service is what's primarily used in this to interact with the users. The only reason that entity manager is still there is because I've been a silly goose and have just realised I don't need it. But yeah, I don't actually need that one, because the auth adapter service, essentially, I have built in some basic CRUD mechanics. For those of you who don't know, CRUD stands for create, remove, update, delete. And the auth adapter service uses those to interact with the database to get what I need. For example, find user. That's something which the auth adapter service handles. Another one being, you can use other methods that I built. I will show you that now. Let's have a look. There we go. You've got delete user, you've got update user, and you've got create user. Does all of that because if you're a user and you have a username and password, which you do, this is a system that instead of me having to write out these queries myself, it's a lot easier to just build an object for it that I can get the methods to get that for me, which is what this does. And it uses that entity manager as well. Now, the other thing to mention, you'll find compared to last time, is for all of this we're using inject. For those of you who don't know, inject essentially allows Micronaut, once you've highlighted the kind of bean, in our case singleton, to be able to manage it themselves and for Micronaut to create that when it's built. Now, singleton is used to essentially tell Micronaut, right, when you create this, I only want you to create and manage one of these. I do not want several. Now, you're probably wondering, well, why is that important? Well, similar to me using this authentication service, other services, like for example my task management, also need to inject adapt services and inject other kind of services. There's a lot there. Without having that highlighted as a singleton, what can end up happening is you end up with multiple different beans. So what that means for Micronaut is that it will have multiple different beans of the same object that it's trying to manage. Now, is that necessarily a problem if they're all doing the same thing and you only want one method? Not really. What does make it a problem? Well, what makes it a problem is it is quite taxing on memory. You got to consider, guys, that this project is relatively small, or small to medium, I'd probably say. But some of the bigger ones that have a lot more beans to manage, if you start to have multiple of those beans, memory can very, very quickly go up and up and up and up. And it makes it slower, it makes it not as responsive, all the kind of stuff that really we want to avoid. Now for myself, when we go over to that authentication, that service, just authentication service, that's why we use it. And you'll find that that's the same across quite a few that I've used. Now, probably wondering, in my authentication service, authentication success for a response. Now, what does that mean? Now, what that means is we're using JSON web tokens. What that means is there's a secret that I have in my YAML. Now, every single time a user verifies successfully, they get given a token, that token is signed. Now, that's signed with this, which is a password. Now, when it's signed and it gets put on the token, it allows for what's called essentially stateless security. So it used to be, if you wanted to have this kind of thing, you would store like session ID information. So you know about the session that the user's on, and the server would have to remember that so that if you sent a request, it'll go, yeah, you've already been on, you're fine. What the signature allows it to do, instead of it having to remember that, signs the token, chucks it across, client catches it, and then whenever client then goes to get something, it will then provide the server that token. The server will read the token and go, yeah, that matches, it's still valid, it's not expired, it's fine, we can give you the information. Now, when you consider multiple people, all who might be using a website at the same time, that's when JSON web tokens really, really shine. Because instead of the JWT tokens having to, instead of the server having to remember each individual session, which can slow things down, cause things to crash, really quite bad. Instead, it goes, right, it's got a token, it's signed, it's got the right signature, take it back, off you go. Simple. Makes it a lot easier for people. Now, when it comes to the success, there's two kind of arguments that I've used here with authentication response. For myself, what I've used is the username. So that's the kind of user, so to speak, or the name on the token. And we've also attached the roles. Now, the reason we've got the roles there is when you do a token, there's a couple of aspects you get. You get usually an expiry date, you get the actual token itself, which is the actual token. You also get the user, and you can also add roles. Now, the reason why I'd add roles is when the server gets the token, if, for example, a user isn't allowed admin privileges, if you've included what role that token is under, server will look, go, he's not got the right privileges, he's not the correct role, so whilst he is through to do XYZ, he is not allowed to do this, therefore he's rejected. And that is why people use it. It's that simple. Now, how does this work in our code? The last time I spoke to you guys, we built the task management service. I showed you it. One thing we've not added is on the controller for our task management service, we can use the @secured annotation. Now, when you do @secured annotation, what it allows you to do is put in the list of all the roles of who can do what. So, for example, if you put @secured on top of the class, it means anyone who wants to access any of these methods have to either be a user or an admin role. If they're not, it'll come back as unauthenticated and it will reject it. Now, why is that useful? Well, say if you had a method or a a table, let's say, that a method used that you didn't want a user to have any interaction with. You could use @secured on that method, just at the top, but instead of using, including both, you might just take out the user and leave admin. So only admin people can use that method. And that is exactly why it's used. Now, for yourselves, I would encourage you to give it a go, start using it, because it is very, very common and very well used across the industry. So I would certainly make sure you have it there. When you look at most things to do with security, I'll be honest with you, especially when I've done a lot of research, web tokens really seem to crop up quite a lot because they are very, very good in performance and also very good in what you can actually do with them and what you can add. You can generate your own custom tokens, you can add anything extra you want on it. It is very, very kind of manipulable, shall I say. Now, the next bit that we'll go through is our registration service recap. Now, what I've showed you there is just for the authentication. We've also done a registration service since I last did this. Now, this implements some of the things. Okay, we've got the auth adapter service, we've got the entity manager as well, we've got password hash too. Now, the register simply takes the user details model, which is no different from what we had beforehand. Just has username, password, role, and then email is the other thing it has. What it will do is it will hash the password first because we need it hashed. Then it will go through and check to see if the hash password equals null or if the hash password is the same as the original. Now, why have we done that? Essentially a checker. Because if, for example, it fails for any reason, it will log it as an error and it will throw an illegal argument saying the password cannot be hashed. The reason it will do that is if, for example, something was wrong with the password hasher, instead of it just going through anyway and letting it send the raw password, we cut that off at the knees straight away. One thing I found really helpful, guys, in this project, and I'd encourage you to have a look, see if it might help you, writing down flowcharts. So if the program does this, this, and this is the path it will take. What do I need to consider? The reason it's good to do that is when you're doing this, some of my mentors I've had in the past have described it as a happy path and a bad path. Happy path is what happens when the user has the right information. Bad path is what does the code do when the user has the wrong information. And you can spend quite a bit of time, I'd say it's good to, just noting down what could possibly happen. Now, I'm not saying go down a rabbit hole of writing everything, because realistically, you're not going to cover that much. But think about some really simple, like basic paths of where your code might end up and what you're trying to achieve, because that's how you can add things like this in place to just help check whether something could happen that you don't want to happen, and you can put things in place to avoid that. As you can see, we've got in a try block the save user section, which essentially creates the user and sets the password to be the new hashed one. And then once it's done that, it will then check to see if the user's already registered. If the user's already registered, then it will say that the user already exists and it won't let them do it. If the user hasn't already registered, it will set the role as user by default, followed by create a user. Now, why have I done it that way? Well, in our case, our registration service is designed for users. It is not designed for anyone with admin privileges. So what does that mean? Well, if I was doing this for an admin user, what I could do is I would probably do a separate service for them. The reason I do that is this admin side might want to have higher functions or might need access to more methods, whereas the user really doesn't need that. They're quite basic on what they need. They don't need loads, and as long as you have, as I said, the user or what you're trying to do, you have it there, then you can think about the other stuff down the line, which is exactly what we've done. The whole point of this project is to let the user operate it, and that's what we've done. If there's an error, we've got the catch, so it will throw an error, except registering user, and it will catch that. Alright? That's it for the registration service, guys. Now, the flow as for that one really is quite simple. Create the password, hashed, check whether the user's there. If the user's not there, then create them. If the user is there, then don't create them. And also set the role to be user every time. So nice and simple, guys. Alright? Now, what might you want to do as well? For our case, for the authorization adapter, that's I've already went through, but that really hasn't got anything majorly different. I'll be honest with you guys, most of it is just using the entity library and accessing its methods, whether that's creating queries myself, or, for example, just using some of the methods without having to create a whole query. We won't be going through that today. Now, the next stage, guys, is also talking about the fact that we've used our game service. Now, the game service is something we're currently implementing. This is something that I'm going to operate more on going forward. The game service essentially is our next stage of the development of the app. Now, what this means is instead of having, say, just a to-do list, I thought we're going to make it a bit fun. So how are we going to do that? Well, we're going to do another service that's called game service that will essentially award someone XP and levels for completing tasks. And this is the main big thing that we've added today. A couple of things I need to go through to show you how this works. We've added a new table, okay, that is player stats. That's one you've not seen before, guys. That's got a user profile ID, username, password, username, player level, player XP, and XP to next level. Now you're probably wondering, why didn't I just add that on the users table? The reason, guys, is quite simple. The users table is there for user information, not for player information. Now you're probably wondering, oh, but that's just adding more time. Why do you want to do that? Well, separation of concerns that applies with the Java sort of also really applies when it comes to tables. Now each of them serve their own purpose. The users serves the purpose of getting the username and password. The player stats serves the purpose of keeping track of progression. And the reason I've kept them separated is it keeps things modular, keeps things easy to edit, and if I wanted to add anything extra, for example on the player stats, I wouldn't also have to do that on the users and end up having like 10, 15 columns, which can get very confusing. In our case, the game service uses that entity along with the player stats to go through and award players points and things similar. In our case, we built an adapter for it. Now that really is quite similar from the existing one. I will go through that. We've got the persistence context for entity manager. Once again, it's taking that entity data source that we've got and it's using that to get what we need. Got a logger as well. The mapper, now that is the exact same as what we've used previously. And if you haven't seen previously, you've used map struct, which is a way of changing an object from one type to the other. The key thing in order to do that is you have to make sure the attributes naming matches and they're both the same types, as in the actual attribute types are the same. In our case, we have done that already, so I'm not really going to go through that one. We've got that injected because we only need Micronaut to manage that. We don't need to manage it ourselves. It is an interface, so we don't need to declare it as a new one, and Micronaut is managing all of that. We've used comments for this, so create, so you've got the player stats model, changes it to an entity, persists it, logs it. Alright? One thing to know, guys, and I didn't actually know this until recently, when you're using the logger, you can use these here, which are like the curly brackets, and then afterwards, as a second argument, you can also add in what the kind of filler is. In our case, we've got player stats created for username, and it populates it in for you. That's one way you can do it. You can still use the $ along with the curly brackets if you want, but it's really a personal choice, to be fair. People choose to do it in whatever way they want. Got a catch in case of any errors, okay? Really important to have the catches, especially for the CRUD. If anything goes wrong, you want to be able to manage it in a reasonable way, and you also want to be able to log it so you can see what's going on with it. Alright? And the reason why I've used the logger, for those of you who don't know, I didn't mention this last time, it's something I've recently used. What the logger allows you to do is to, essentially, when it's running, and I'll show you that now, here for example, you can log different sorts of things. So for example here, you've got like debug, you've got trace, for example. You've also got something that you can use, error, it's another example, and there's also some for what's called info. Now the reason I've used that is when you're using a logger, if anything goes wrong, you can kind of specify what kind of message you're giving out and then the context. Whereas when you use system out print, it's just printing a raw string. That can be a bit hard to manage. And if, for example, you wanted to color code it, so for example, errors come up as red when you look at your terminal, I've done that. So if something goes very wrong, instead of me having to read through each line, I could just go straight to that. If it's information, once again, I can look for info, find it there. If it's a warning, same thing. All right, there's lots of things you can use. I would encourage you guys to really have a look at that because I found it much better than using the system out prints. And you can have one per class, which is good. Next bit for that one is the retrieve player stats. Now that one's quite simple. That takes the authentication, okay, that the token has. Keep in mind, guys, all of these methods, when they're accessed through the controller, that token is provided. We can use the username on the token that we gave to then get a user, for example. Same with player stats. That's an architectural decision that I've made. You don't necessarily have to do that. You could add a whole new object model if you wanted to. I've done it that way because I see no reason why I'd need anything else. Right? Something you might be able to use, just to keep that in mind. Gets the name for the authentication, and then it searches using a parameter of that username in the table to see where it matches, and it will return it. Now, if it's not there and there's no result, then it will warn no player stats found for user, and it will return null. If there's no result, and if there's any other kind of exception, that's when it will log it as an error. Okay, but it's one of those other things. The no result exception is something I found which you can use. Now, for those of you who don't know, because this took me a while to learn, the exception, when you use it in a catch, exception is a class. Under that exception, there's lots and lots of other kind of exceptions. Because Java is an object-based language, and it uses object-oriented programming, you'll find that most things are all objects, whether that's libraries you use elsewhere, whatever it is, it's all an object. Exceptions are no different. Exception is a hierarchy. When you go down under that, that's when you start seeing all the different kinds, illegal argument exceptions, null pointer exceptions, all of that kind of stuff. And that's one really cool way where you can customize what it feeds back and what's caught based on the exception provided. Next one is update player stats. So that takes the new player stats model and the authentication, gets the name, searches for it, returns it, and then alters anything that's needed. All right. Same thing with the delete player stats, takes the authentication, searches it, removes it. If the entity doesn't equal null, it removes it. But if it does, say there is a entity there that already exists, then it will come back with an illegal argument exception. All right. Same with the no result exception and the normal exception as well. That's it for the adapter service. For the actual game service, this one is a bit more interesting. Got a couple of functions here. I'll go through them and we'll see what we get. So for the first one, you got that add a new player profile if it doesn't exist. Now the reason we've done that is not all users straight away are going to have a profile. And what I don't want to do, and this is a good tip for you guys, don't start mixing methods that should belong to another class into something else. What do I mean by that? Well, the task management service, for example, arguably that needs to know the player stats. I'm not going to then start to create player stats in there because that is not the task management's responsibility. This is the game service's responsibility. In our case, it creates the entity from it, from the user details. Once it's done it, it sets them as a basic player level 1, 0 XP, and XP to next level. Alright, that can be altered to whatever you want it to be, guys. And then it creates the player stats and catches any errors. Next one you'll find is calculate XP. Now, I've done this in a way to help with leveling. Now, what does that mean? Well, I'll give you an example. I played Battlefield 6. Best game in the world. Love that game. It's amazing. But in that game, you get it's harder and harder to level up the higher up you go. In our case, what you'll see we've got is the task object model and the authentication. It will first find the base XP. It does that by looking at your level and timesing it by 20. So if I'm level 5 times by 20, I get 100 XP. That's what you get as standard. Gets the user, and then once it does that, there's another one for level scaling. Now how that works is it will do math max, which essentially means it has a maximum of 1 minus the user get player level times by 0.02. So essentially, if the user was level 7, it'll do 7 times 0.02, which is 0.14. 1 minus 0.14 will equal, what's it called? Will equal 0.76. No, 86, yeah. 0.86. That's bad then. Yeah, 0.86. So that means you get the 0.86 is the level, and then it will use that to times the base XP, which in our case was 100, times by 0.86 to find out the total XP earned. Now, the reason it does that is if, for example, you were a higher level, you will get slightly less and less XP to make it harder and harder to level up. And that's there to help keep the game interesting and to stop it from being the same level of XP every time. And it also means it's very repeatable because I don't need to add anything in here. The XP will get calculated and will vary based on that level. That's it with that one. I'm just going to check something as well, guys. 1 second. There we go. Yeah. There we go. Wonderful. And what that will essentially do as well, just a quick note for you, the max bit here, okay, that will look for the highest one out of the 2. So in our case, we've got 0.4. Now, why have I done that? Well, if you're level 100, then you're going to end up getting a lot less XP. So at base, the minimum that it will be, and it can't go any lower than that, is 0.4. And math max will look for the highest one, which is, in our case, if that did happen, we were level 100, 0.4. It logs the info and it returns the total XP. Now for yourselves as well, the thing to keep in mind, adding XP for completion, that will get the task object model and authentication. It uses that to calculate the XP with that method above. Once it calculates it, it'll map the player stats model, okay, using the... Got my own mind then. Yeah, brilliant. It'll get the player stats that we get using our authentication. It tries to find it and then it maps it to a model which we can then manipulate. Once it's got to that stage, we set the player XP to be what it is plus the XP that is earned, and then after that it does a check. Now it checks to see if the XP that they have is greater or equal to the XP to the next level. If it is, then it levels up with that authentication and it will log it. If it isn't, then it will log the fact that they've not leveled up, and it will then also just return and update the new player stats. The level up function, quite simple, guys, takes the player stats model, and it gets that from the authentication, and it will see the old level, and it will add one to it. Why have I done it that way? Well, you might want to add something else. So it might be more than one level they can add up, or you might want to have prizes or things like that. If that's the case, then the reason it's stored in variables is I can add, for example, if old level is 50, if old level is 25, give XYZ. In our case, not needed. We've got some carryover, leftover XP, instead of resetting to 0. How that works is the overflow XP is going to be the player XP minus the XP to next level. And then if that is less than 0, the overflow XP equals 0. If it's more than 0, then it simply just adds that on to the new XP after they've leveled up. And for the next one, it'll be set up next level, uses calculate new level up threshold, which takes that player stats model. That just allows you to change and alter what XP is required for each level. In my case, and I'll show you this one, guys, we got that method there, just times their player level by 20, and then that's how much you need. Same with the calculate XP to level up. It takes the authentication, finds it, sees what the XP to next level is minus the entity XP, and then if when it gives back the result, it then allows you to manipulate it. Alright, that's simple, guys, nothing else with that one. That's it for the game service. Really, there isn't much else. That is pretty much what we've got through thus far. Haven't had a chance to implement that yet. We're still working on making sure it works with our front end, and that's something that we're going to look at doing. What I was going to show you guys as well is a quick demo of what the actual login now looks like. We haven't had a chance to do that yet. So if I go over to my service, it's still running. Just double check that. It should be. There it is. Right, if we go over to our login, and I'll show you that one. So much stuff open, guys, it's scary. That's another thing. Keep your stuff closed. Don't be like me, but loads of stuff open all the time. It's ridiculous. Right, this is one user called Freeze. Password is, as we all know, the super secure and unbelievably unguessable password, which is actually password. Now, once you're on this, you simply sign in, login successful, comes up, and it shows any tasks you have. In my case, Freeze doesn't have any tasks. Lazy. But some of the other users do. And you'll get your tasks, and then you can enter and edit as you have. What are we going to look at doing in the future? Well, I'm going to be looking at doing some cleanup, specifically with variable names and method names. That's not something I've already talked about on the channel. But yeah, that is one really important point. You'll see with my repo, I am going to be, pushing that today. But for you guys, it'll be already done. I'm going to push that today. What you'll find is some naming conventions that I've got on my own code is not on par with what it should be. Naughty. We won't be doing that. We'll be fixing that. Yes, I'll be fixing that, guys. I'll also work on a search function for my task name. I do want to start implementing that at some point. And I also am going to work on this game service. Once we've done both of that, hopefully I can do that in my next video that I'll show you guys and get that stuff sorted. Then it'll be looking at doing another cleanup, and then once it's fully cleaned up and how happy everything is as it should, we will then be moving on to actually deploying it. Now, how am I going to deploy it? Well, I'm going to use Docker. What I'm essentially going to do is turn my backend into an image, and then I'm going to use a netty to essentially handle communication from my front end over into the port that container will be running on. And when I do, I won't have to change anything, but it just means that Docker container could be ran on my machine, but also could be ran on other people's. And that's going to be a completely new stage for me in the kind of pipeline of building applications. So it'll be interesting to see how that goes. And that is where we are, guys. There's really not much else. We've pretty much covered. Check my notes. Yeah, wraps up day 5. Or 4. 4. Day 4. It's not day 5. Yeah, that wraps up day 4, guys. I hope you enjoyed the video. Please let me know down in the comments below. I really do appreciate your feedback as well. I had a lovely gentleman, quite kind. He gave me a bit of feedback on the volume music-wise. Let me know, guys. Really, it's really important to me that I can help produce the best content for you guys as I can. But have a look. Let me know what you think of the videos. Let me know whether there's anything you'd like to see. and we'll certainly endeavour to try to do that for you. And once again, I appreciate all of your support, guys. You all mean the world to me, and I will see you on the next one. Take care, guys. Bye bye.